Good morning and afternoon. Here are some special right triangles, and I mean super special. So special that they are the predominant triangles that we use in construction and any type of just general shape interactive device, anything. It really hinges on these 30, 60, 90, and 45, 45, 90 triangles. And that's exactly what they're called. So this is called a 30, 60, 90. Are you seeing where that comes from? 30 degrees, 60 degrees, and 90 degrees. And then there's the 45, 45, 90 degree triangle. And the first is, we'll deal with is the 30, 60, 90, my favorite. What it has is the sides have a particular ratio to them. So here's two more 30, 60, 90 triangles. Again, I'm not drawing these really pretty like, you just have to go by the markings, right? You're going to just indicate. So there's a 60 degree and a 30 degree, and here's a 60 degree and a 30 degree up top. Imagine these are beautiful right triangles, not what I drew. If the hypotenuse is 2 on a 30, 60, 90 triangle, the shorter leg of the two remaining, so I'm going to highlight that, there's the short leg, is half of that, so it'd be 1. And then the next leg is always whatever the short leg is times the square root of 3. Now, it sounds funny, I know, but that'd be 1 squared, it's a 3. So there's this cool pattern between it. The hypotenuse, cut it in half, you get the short leg. Take the short leg times the square root of 3, and you get the long leg, which is on the right-hand side. I'll do it again with another example here. These are different pen colors, so it stands out a little bit. If I say this side is, the hypotenuse on the bigger triangle is 4, for instance, then the little short leg down here would be 2. And the longer leg, and when I say leg in a right triangle, I mean the ones touching the right angle. That would be 3 square roots of 2. So this, and I'm sorry, 2 square roots of 3. I said it backwards, didn't I? There's 2 square roots of 3. So whatever you have on the short side times the square root of 3 gives you the long side, the long leg. This is pretty slow. Now, this is a cool thing about it, too. You guys can always check this with the Pythagorean theorem. So those lengths that I gave you just a moment ago. So if this bottom here, the last one I wrote was 4, 2, 2 squared roots of 3. And if you do the Pythagorean theorem, you'll find out that 2 squared plus 2 squared roots of 3 squared equals 4 squared. If you take those values, square this and get 4. And if you square 2 squared roots of 3, you actually square both of these. So that would be 4 times, and when you square a square root, so you know that square root of 3, if I square it, they're inverses, I actually just get 3. So the 2 squared is 4, the square root of 3 squared is 3, so 4 times 3 is just 12, and 4 squared we all know is 16, so hey, look at that, 4 plus 12, which is 16, equals 16. So this is just, it is the Pythagorean theorem in here, but it just so happens the ratio of the sides in the 30, 60, 90 has the same pattern we use over and over and over again. So here's one last way to look at it, and then we're going to start solving some of these to give you guys an idea how this works. So I could even put x as the hypotenuse, then the short leg would be x over 2, and the long leg would be x over 2 times the square root of 3. So remember, whatever the short leg is, you multiply it by the square root of 3. What I haven't done is invert this and turn it in other directions, and that's important. So now I'm going to turn this around a little bit. So things like, hey, here's another 30, 60, 90, turn on its side. So what if I said the long side was 5 squared roots of 3. Now the cool thing about a 30, 60, 90 triangle is that you can actually take one side of a 30, 60, 90 degree angle and find all the others because you know the relationship between them. So if I know that the long leg is 5 squared roots of 3, you got to think back. The short leg is, remember, something times the square root of 3 gives you the long leg, and so, well, hey, I got that something. This would just be 5 on that short leg, because the longer leg is 5 squared roots of 3. You just remove the square root of 3, and you've got the short leg. And do you remember that the short leg is half as big as the hypotenuse? So then I can come up with the 10 for that one. So it's nice. You can take 5 squared roots of 3 as the long leg, take off the square root of 3. Now, that taking off, I'm actually dividing by that square root of 3. So this is 5 squared roots of 3, and I'm just dividing off. I'm unmultiplying that square root of 3, and that cancels, and it gives me just 5. And of course, you guys know going from 5, the short leg, to the hypotenuse, it's just twice as much. So I doubled it, and there we go. So you can always find missing pieces. So let's try a couple more, though. Now this time I went for some really nasty-looking triangles so that you kind of focus on, when I say the long leg and the short leg, the long leg is always along where the 30 degree and 90 degree are at, because that pinched 30 degree angle is where the triangle kind of got pinched up and made longer. It's easier to see on this left one here. It's drawn a little bit more to scale. but the long leg is always along with the 30-degree angle there. You're going to get a little participation from Ethan here, who's homesick with hand, foot, and mouth. So just so you guys know, this stay-at-home business is busy. We got a sick child, doctor's appointments, babies. Yes, I hear you, buddy. He wants to play with the triangles. He's a big triangle fan. Okay, so all right, we're back to business. So again, I can give you any missing side. So if I give you, I'm going to give you, whoopsie, let's do the pen this time. 15 as the hypotenuse of one of these. You guys know the hypotenuse is twice as big as the short leg. Well, the short leg is along with the 60-degree angle. So down here, if I cut that in half, I get 7.5. And then you know the long leg is the square root of 3 times whatever the short leg is. So that would be the square root of 3 times that 7.5 down below. Maybe I can write that a little bit better. I could put it out of the picture. There's 7.5 times the square root of 3. There you go. Let's go to the other side. If I put in, I don't know if we've done a short leg yet. Let's say the short leg is 3.2. You know, something goofy like that. Well, hypotenuse is twice as big, 6.4. And the long leg is just 3.2 times the square root of 3. And that's it. So you can always fill those in 30, 60, 90. Now let's look at the 45. 45, 90. Similar type, it's a little bit different relationship. Here's something I forgot to mention. Sorry, we'll do the 45, 45, 90 in a minute. So what if I give you a long leg here? So remember, that's where the 30-degree angle would fall. If it's 10, a whole number in there, to get the short leg, remember, we have to, it was the short leg times the square root of 3 gives you 10. Well, I'm going from 10 to the short leg. I'm actually going to, remember, divide by the square root of 3. Or better yet, this is the short leg is just 10 divided by the square root of 3. So when you're working backward, you divide by the square root of 3. When you're working forward from short to long, you multiply by the square root of 3. So here's working backwards, so 10 divided by the square root of 3. And then still, the hypotenuse is still twice as big. Twice as much as 10 square root of 3 is 20 squared over the square root of 3. And I don't know if I said over the square root of 3 carefully. So you can divide by the square root of 3 when you're going from the long leg to the short leg. Take note of that. That's important. We'll do it with the 45, 45, 90 as well. All right, 45 degrees. The relationship's a little bit different. The legs, of course, 45, 45, 90. Did you notice that's an isosceles right triangle because the base angles are congruent? So if I say this is 2, hey, the other one's 2. And then cool thing about the hypotenuse, it's times the square root of 2 bigger. So take a quick note of that. That's really important. So times the square root of 2 bigger. So it would be 2 square roots of 2 in this example. Now let me back this up. Put some other in there. So we're going to go, let's say this is 3 times the square root of 2. You kind of catching my drift there? This would be 5 times the square root of 2. So it's not as many things to remember. It's just times the square root of 2, whereas 30, 60, 90 had that long leg, which was times the square root of 3. All right, here's another. Let's do that backwards thing again. What if I gave you the hypotenuse was like 10? In this one, instead of when you're going backward like that to a smaller leg in there, you have to divide by the square root of 2 instead of multiplying by the square root of 2. So it's 10 divided by the square root of 2. 10 divided by the square root of 2. And that's it. That's the whole process. I should do another one there. Let's do backward and forward, one more each, and then I'll set you guys free. You should be good. So if this is 7 times the square root of 2. That's all that is. Okay, whoops. I wrote a square root of 2, 7. Now let's say I put in hypotenuse in this one, so it's 16. Well, the short leg would be 16 divided by the square root of 2 because I'm working backward to a smaller leg. I'm dividing by the square root of 2 this time. So 16 divided by the square root of 2. And that's it. All these with this radical stuff, square roots are called radicals. You leave them. You don't find the decimals. Don't go get decimals. Leave the square roots in there. And you should be good to go. Email with questions. Put them on Twitter. You name it. I'll look them up and get back to you.